Okay, so we are going to be working on two sections today, section 4.3, and then we're going to go over to section 4.4. So we have two sections to get through. In our next class, we're going to do two sections also that will finish us up for chapter 4. And then we will be ready to take test 3, which will be covering chapters 3 and 4. Okay, so let's look at these notes. And so we are working with finding values, and it is called the inverse z-score because we're taking the z-score and solving it for a different variable instead of z's. So we're actually going to be finding x, finding the values for x in this. So finding values. So if you have notation wise and you want to use a letter, I always use x for these values. In this new notation, we have that p is, and then in parentheses, z is greater than c. Okay, so that means that the probability of z is greater than some number, and we're calling the number c. And it's the same thing with the next notation, only it has the less than. So p of z is less than c. That's what that notation means. So I have instructions on here because it is kind of confusing of what in the world does this mean. If you're trying to find c in that notation, and it's going to have an equals something. So you can see the example down underneath. P of z is greater than c equals, and then I have 0.7263. So in order to find c, you would go into section 3 on the Z and T on Excel, type in that number under section 3, and the probability to the right, since this is greater than, and then underneath it'll give you your value for the z-score. Okay, so that's what we're looking for here. So you're looking for z in that kind of notation. We are going to be using interval notation, and interval notation means we have to use brackets or parentheses. When you use brackets, it means the endpoints are included. When you use parentheses, the round parentheses, that means that the endpoints are not included. For our questions, they will tell you whether to use the square brackets or the round parentheses. Okay, so just pay attention to what they're telling you to use. But always type your lower number first, then type a comma, and then type the upper number. Okay, always type them in there in numerical order. Okay, then we have what this section's really about, using the inverse z-score section 3 to find your values. Okay, and values is going to be x on the sheet. So if you are given mu, which is the mean, and you're given sigma, which is your standard deviation, and then now you're given a percentage. So the percentage, it could call it a probability, but it is a percentage. You're going to type the numbers into section 3 on the Z and T sheet. So the percentage should be entered in the right or the left, depending on if it says greater or less. And then, you know, those keywords that we have. And then if you have percentile, percentile always means under. So always use probability to the left for your percentile. Remember, we had the capital P and then a little number down below it, like a subscript. So that means percentile. Okay, before we look at the recap, which is a good time to have a recap since we've had spring break and we're coming back and jumping right in. Let me talk about section 3 here, and you can see it goes across instead of going down. So section 3, we have mu, population mean, We have sigma, which is a population standard deviation. We're going to skip that sample standard deviation because we don't have that one. Sample size, we're going to skip because we're not going to know our sample size for this section. But then if you go over here, probabilities, you either have the probability to the left, probability to the right, or the probability between. So you need to use the words. If it is something that is talking about less or lower, then you want the left. If you're talking about something being longer or greater, you want the right. If you want something that's between, so with between, we had middlemost, we had within, that's another word for between. So those are the key words you're looking for so that you know where to put your percentage. The percentage is going to be your probability. Make sure you change your percent to a decimal number. So move your decimal 2 places to the left and drop your percent sign. But we're not looking for z-score. Even though the z-score is going to be there, we're looking for our value. And I think you can see it here, calculated value or sample mean. So it's going to be our value for this section. Okay. Sample mean is what we're going to have in a little bit. So don't want to get confused right now. This is the calculated value. So that's what we're going to be looking for. We're finding values. In real life, we don't ever go around and talk about z-scores. We talk about values. What is the probability that all the class is going to pass with at least a 70%, right? So that's what we want to know. I'm not going around saying, what's the probability that your z-score is going to be greater? You know, we don't talk about z-scores. So we're looking for values. So these are going to be more like situations that you're dealing with where you're looking for the value. Okay, so let's look back on our notes. The right one. Okay, here's a recap that's going to kind of help us distinguish between these 3 different sections on Excel, which really do correspond to the 3 sections that we had in our notes. So 4.1, 4.2, and 4.3. But it is section 1, section 2, and section 3 on our sheet. So if you are only given your z-score and the question says find your probability, you will go to section 1 on the Z&T sheet. When you are given the value, the mean, and the standard deviation, and then the question is asking you to find the probability, use section 2. But when you are given mu, sigma, and your percentage, and the question says find your value, that's when we're using section 3. Okay, so use that little recap to help you figure out which one of the sections that you're supposed to be using. Let me show you a little bit better here. In section 1, if you only have your z-score, okay, you would be in section 1. And if it's asking you about probability, okay, even if it's a between and you have 2 z-scores, that's when it's asking you for probability. But in section 2, if you have your value, which is X, you have your population mean, which is mu, and your population standard deviation, which is sigma, and they're asking you to find probability, section 2. Okay, so the first 2 sections help you find the probabilities. But if it is asking you for your value, that's when we go to section 3. It says find the value. And then what they will give you is mean, and then standard deviation, and a percentage. That's when they'll give you the percentage instead of all you looking for the percentage. Okay, so that's the main difference with sections 1 and 2 compared to section 3. In section 3, you will be given that percentage and you're looking for your value. Okay, it's really important to know which section to go to, right? And that's usually what most people say. I have the hardest time trying to figure out where to go. So make sure you use that little recap to help you figure that out. All right, so there are 6 questions in here, but these are not hard. These are pretty straightforward. As long as you remember, we're in section 3 for most of it. We do jump up to section 2, I think, for one of them, but we are in section 1 or section 3 for most of these, starting with question 1. There's a couple that we are going to be in section 2. Okay, so look at question 1 for this in-class assignment. A manufacturer knows that their items have a normally distributed lifespan. So that means we can use the Z-score since they are normally distributed. Okay, then they give you the mean and the standard deviation. So that's mu and sigma. So right off of that, you have your years, which is your mean, and then a years for standard deviation. The question says the however many percent, your percentage of items with the shortest lifespan will last less than how many years? So that less than is meaning probability to the left, and that percentage is your probability. So go ahead and type these numbers into section 3. Okay, now, you guys that are looking at the screen, I have to jump over. So mean goes in the first box, standard deviation goes in the second box, but I have to jump over because I have to deal with my percentage. Since this says less than, I want probability to the left. Make sure you change that to a decimal number. I took my 2% and I made it 0.02. So make sure you move your decimal 2 places. We're looking for our value. So we're looking for the bottom number. We're not interested in Z-scores. The question wants how many years. Okay, they want the years. They're not interested in Z-score. Anyone have any questions about number 1? Okay. Just make sure you're in the probability to the left for that one since it says less than. Okay. Number 2 is very similar. Okay, number 2, same type of thing. It's about fruit. A particular fruit's weights are normally distributed, and they give you the mean in grams and the standard deviation in grams. The heaviest certain percent of fruits weigh more than how many grams. So we're looking for grams, so we're looking for the value. So our percentage, since it says more than, we're going to put this one in the probability to the right. So start at the beginning, clear everything out of here, and do your mean and standard deviation first. Get those in there. And then tab over to the probability to the right this time. Have to watch those special words, less and more, or anything that's associated with less and more. In the last question, when it said less, it talked about shortest. That kind of gave us a heads up that we're going to be doing something with less. This one says heaviest, so more, but really the less and the more are the words that you're looking for. Anybody have trouble with 1 or 2? Okay, let's go on to number 3. This is the one where we're gonna kind of skip around. This is gonna show us when we're using section 2 compared to when we're using section 3. It says, company XYZ knows that replacement times for the quartz timepieces it produces are normally distributed with a mean and a standard deviation. So you're going to use that mean and standard deviation for both parts. First of all, for A, the question says find the probability. We're not looking for a value. So since we're not looking for a value, we are not given the probability. We're finding the probability. So that's in section 1 or 2. Okay, but it already gave us the mean and the standard deviation. So we are in section 2. So go to section 2. You can type in your mean and your standard deviation, but let me finish reading this problem. Oops, put them in the wrong places. There we go. I wasn't paying attention. Okay, so type in your mean and your standard deviation, but part A, so find the probability that a randomly selected quartz timepiece will have a replacement time less than, so we know we're looking for probability to the left, since it says less than. The less than tells us left, but they give us a value. The value is X. Okay, so the value is the first number. Don't do what I started to do. I typed in my mean up there. The mean goes under mu, and the population, the standard deviation is sigma. And then the value is the last number that you were given. That's the top number. And we're looking for less. So copy your left. Everyone see why we went back up to section 2? We're finding probability. If you are given probability, you're in section 3, but we weren't given the probability. We were given a value to compare it with. And so that means section 2. For part B, if the company wants to provide a warranty so that a certain percentage, that percentage is a probability, by the way. So that this certain percentage of the quartz timepieces will be replaced before the warranty expires. What is the time length of the warranty? We're looking for a value. They have given you the probability, that's the percentage. So you're looking for a value. So this time we have to go down to section 3. And we're going to type our mean and standard deviation. Okay, and go over to, which one do you think? It says, so that only a certain percent will be replaced before the warranty expires. So do you think this is going to be probability to the right or probability to the left, since it says before? Left. So type this in, your probability to the left. Make sure you change it properly. Move your decimal 2 places to the left. Okay. We're looking for a value. Anybody have any questions there? Okay, so far so good. Okay, we're halfway done this already. Let's go to number 4. I like number 4 because it gives you that percentile in the notation that we use for percentile. Okay, so on your question, you see how it has the P and then the little subscript? That's what you want to pay attention to. Don't pay attention to something that it says in this problem where it talks about separating. That is confusing. Okay, we'll read that in a minute. Start at the top, it says a company produces steel rods. The lengths of the steel rods are normally distributed with a mean of a certain number of centimeters and a standard deviation that is a certain number of centimeters as well. Find the percentile, and then you have your little subscript. Mine says P38. Okay, 38th percentile. That means 38 under and 62 over. Okay, that's the separation. When I add 38 and 62 together, it is 100%. So you don't need to pay attention to that part. What I want you to pay attention to is the P with the little subscript. Use that little subscript, make it a decimal number, but use that little subscript in your probability to the left. Okay, we are finding the value. That's what we're looking for. So type in your mean. This is section 3. Type in your mean and standard deviation. And percentile is probability to the left. And we're looking for the value. Notation's important. So when you see that P and the little subscript, that means percentile. Percentile always goes in the under. So that's always left. Anyone having trouble with 4? Okay, let's go to number 5. Number 5, it's kind of generic, but the reason I have it is because it says middlemost. Where do we go for middlemost? What does middlemost mean? Does it mean right or left? No, it means between. So this one has the between. It is a kind of a generic question though. A distribution of values is normal with a mean and a standard deviation. Find the interval containing the middlemost. And it gives you your percentage, which is your probability. So you have to type in your probability between. Here's what you have to remember. Look underneath the answer box. It says enter your answer using interval notation, and it has an example using parentheses. So we're using parentheses here, not the square brackets. Okay, so that's all you have to think about is make sure you're using the right notation. This is section 3. Okay, so type in the mean and standard deviation and go way to the end for probability between. Type your probability as a decimal, and then you have to copy these, and I try it different ways. I like just to copy them one at a time. Put my parentheses before and after. They actually rounded it to 1 decimal place. You would use regular rounding rules if you're going to round 5 or up, makes it go to the next number. 4 or less makes the number stay the same. Anybody have any questions for 5? Okay, Let's do our last one for this section and then we'll go over to the next section. This is a hard problem though. Okay, this is going to take us a little while because this is one of those questions that we're comparing two different tests that are on different scales. We've already done one of these before in the in-class, and you've done several on homework so far. So we're just going to get used to these. It says for question 6, a study was conducted on students from a particular high school over the last 8 years. The following information was found regarding standardized tests used for college admittance. So here's the SAT and the ACT, and it gives you all of the mean and standard deviation for both. Okay, so the SAT has a larger number than what the ACT has, and that's why we need to compare them using Z-score. Now, there are different ways to do this, but I'm going to stick with the way we did it the other day. That way, it's not teaching you another whole new way to do it, but we are going to look at this the same way we did it before. It says if a student gets an SAT score that is the whatever percentile, find the actual SAT score. And then we're going to do the same thing with the ACT. So I'm dealing with a percentile. We're all dealing with a certain percentile. Section 3 is where we start. Okay, so go into your section 3. This one is dealing with SAT first. So I am going to use my SAT information. So type in your mean and standard deviation. This is the SAT information since I'm looking for the certain percentile for the SAT. Percentile is always probability to the left. So I need to type in my percentile as a decimal. Should check it. You can check it, make sure it's okay. Anyone have any trouble with that first one? It says you can round that to a whole number. Usually that you don't have to, but be careful on ACT scores. Usually ACT scores on this program really do require us to round it to 1 decimal. I don't know why, but sometimes it does, sometimes it does not. So if you get it wrong the first time, check to see if you need to round it to 1 decimal. For the second question, we're dealing with the ACT for the same percentile. It says, what would be the equivalent ACT score? So if we were talking about a certain percentile for the SAT, we're using the same percentile for the ACT. So look, this probability to the left is going to stay. You're not going to change that. What you need to change is your mean and standard deviation so that you have your ACT information. So these are the smaller numbers, the numbers that look smaller. Bless you. We're looking for the value. I'm going to try using the whole number, all of my decimals, but sometimes, see, it marked it wrong for me. So I'm going to have to make mine be, oh, I got to go all the way up to 21. There. So I had an example where I had to change mine. So you might have to do that. Sometimes that happens with the ACT score. No rhyme or reason to it, by the way. Sometimes it marks it wrong. Sometimes it lets you put the whole thing in. Everyone understand those first two parts? Because that's the new stuff. That's the stuff we're doing now. The third question is going back to what we worked on before when we were dealing with AccuPlacer and high school GPA. But now we're dealing with SAT and ACT. You had some of these in the homework that dealt with first test and second test. Remember those? So it's the same type of thing. So for the third part, if a student gets an SAT score of a certain number, okay, they give you the number, find the equivalent ACT score. We're going to go back to dealing with Z-score because that's how we really do compare these. You can compare these with percentile, which is what we did in the first two parts. But we're going to take this now and deal with it as a Z-score. So go to section 2. Since you are given a value, that's how come I know to go to section 2. See my SAT score of 1255? That is a value. So you were given a value this time. So we're going to section 2, and you're going to use that value along with your SAT numbers. So get your SAT numbers out of there. Now we do have our probability to the left, which is our percentile. So we could use that and go down to section 3 and do it that way. But since we've already learned how to do this using Z-score, let's just keep it the same. We're going to take our Z-score. So make note of your Z-score. Don't copy it, because if you copy it and it makes it gold, then it messes you up. So make note of your Z-score. Okay, here's my Z-score. We're going to go all the way up to section 1, clear over to the right. Type in that Z-score. Then you need the ACT information. And then it's going to give you your ACT score. I'm going to go ahead and just round mine this time to 1 decimal place. So that's what we did for when we worked on it in section 1 and 2. We compared them using Z-score. So you can still compare them using Z-score, even though this section's using probabilities to compare. Whichever way you want to do it is okay. Anyone have any questions with that? Number 6. No? Okay. Let me get rid of this. I'm going to go to 4.4. 4.4 is really short. It is not long enough to do in a day by itself, and I'd rather do it today than to try to do 3 of them in our next class. So this is going to be for homework 16. There's only 3 questions. Let's go to our notes. Okay. Section 4.4 changes a tiny bit here. We have our distribution of the sample mean, which is X bar. So you're going to be given 2 means now. Okay, we've dealt with 2 standard deviations in the past. So now we're dealing with 2 means. Like when we had this to begin with, the very first section of 4.1, of chapter 4, we had a standard deviation and a standard deviations with an S, which turned out to be a z-score. So it always sounded like we had two different standard deviations to figure out which one was which. Well, this is the sample mean. Okay, we are going to have our population mean, but then we're going to have a sample that we're going to pull out. And out of that sample, we're going to say this is the sample mean. So instead of having a value that's called X, we're dealing with X bar being the sample mean. We have this central limit theorem that says if a sample size is greater than 30, you see 30 or greater, okay, that's taken from a population with any type distribution, the sample mean will have an approximately normal distribution, and standard deviation of the sample mean is now going to be called the standard error, which is sigma divided by square root of n. N is your sample size. So now the new part that you're going to be given in these types of problems is going to be sample size. So they're going to tell you this is the sample mean. So if I said I have 100 students for statistics, okay, and in this class, we're supposed to have 15 people in our class, I'm going to pull out these 15, and the average grade of those 15 people is going to be 83%. Okay, so I'm talking about the sample mean. I'm pulling out a sample and the average of my sample. Okay, so that's what we're talking about with this. Now this said n is greater than or equal to 30. So if you have a sample that is small, you are going to have to know that it is already normal before you can go on with what we're doing. So if I said I'm pulling out the 15, then I'd have to say, well, this is a normal distribution. But if what we're saying, as long as your sample is greater than 30, doesn't matter. It can be any type of distribution. So it can be the binomial distribution. And you're still going to be able to look at a z-score because we're going to consider it to be approximately normally distributed. Okay, so the bigger the sample, the closer it gets to being normal. That's what you learn from the central limit theorem. Notation, remember X bar is sample mean. So watch for X bar now instead of X. Okay, now look at the z-score formula from section 2. Okay, it's going to be z equals X bar. Remember, instead of just X, this is X bar minus mu. But when we change to X bar, we have to multiply by the square root of our sample size. So that's where that square root of n comes into play. And then sigma is still on the bottom. Now the sample mean has a population mean of mu. That's what that means. Okay, I didn't type in population there, but mu is a population mean. And it has a standard deviation of sigma divided by square root of n. That is called the standard error. If the population has a normal distribution, then the sample distribution is also normal. So like I said, I could pull out 15 students and I'm not greater than 30, but if I said the whole population is normal, then that means that my sample is normal. Okay, when the sample is large, the sample distribution is approximately normal, even if the population is not normally distributed. So if you have n that's greater than 30, 30 or greater is what we say for our rule. N is greater than or equal to 30, then you can just say this is a normal distribution. The reason we're worried about everything being normal is because you can only use the normal curve whenever you have a normal distribution. So that's why we're concerned with making sure that we're dealing with something that is normally distributed. Okay. All right, so let's go to this in-class assignment and look at these problems. We are looking at section 2 right here. We're on this formula, the one in the middle. So we're not just going to have 3 things to deal with. Now we have n, which by the way is the last box. Make sure you don't put it in your sample standard deviation. We're not dealing with any sample standard deviations yet, but you know that that's what's coming next since we're dealing with sample size. So today we're dealing with population standard deviation. Okay, so there's only 3 questions here. We're going to go through these pretty quick. They're very simple. Just make sure you know that you're putting these into the right section and typing the numbers into the right boxes. A company produces steel rods. The lengths of the steel rods are normally distributed. So it already told us it's normally distributed. So we don't care about sample size, okay? So the steel rods are normally distributed with a mean and a standard deviation. For shipment, this many steel rods are bundled together. Have you ever been traveling and seen these big trucks going with logs or steel rods in bundles? That's what this is talking about. Okay, so for a shipment, they bundle a certain many together. Now it tells us, even though our sample size is less than 30, we can use z-score because the population is already said that it's normal and we know the population standard deviation. Okay, you're going to see some questions about that kind of thing on your homework. Find the probability that the average length, okay, the average length, X bar is the average length of a randomly selected bundle of steel rods is between, and we have 2 values. So remember, when we have a between, we go over to the right-hand side. We are in section 2, but we just need to move over here to our between. The lower value and the higher value here are actually X bars. Okay, they are X bars, not just values, but it just says lower value and higher value. There's not a whole lot of difference between my 2 values here. And then we need the mean from the top because that is our population mean and our population standard deviation. Then the sample size is the bundles. How many's in your bundle? Now something new popped up, which what we're looking for is probability between. Remember, when you're looking for probability, you're in section 1 or 2. For this one, we're in section 2. But something new popped up. Standard error, sigma divided by square root of n. So you don't have to do that formula unless there's nothing to put into Excel, then you have to use that formula. But if you are putting your numbers into Excel, standard error is going to pop up there. Anybody have any questions about number 1? It's almost like we're doing the same thing, but we're looking at it from a different perspective. So I don't want you to lose sight of the perspective. Even though we're doing the same section 2, these are not just values anymore. They are averages. They are values that are averages. Okay. All right, let's go to 2. Number 2. The amounts of nicotine in a certain brand of cigarette are normally distributed with a mean and a standard deviation. Those are population mean and population standard deviations, by the way, populations. Okay, the company that produces these cigarettes claims that it has now reduced the amount of nicotine. The supporting evidence consists of a sample of a certain number of cigarettes with a mean, okay, the average of this sample, so that is your X bar, the mean nicotine amount of a certain amount of grams. Now, if you look at my sample, it did say that they were normally distributed, but since my sample is 30 or greater, it didn't even matter if it was normal or not. Okay, assuming that the given mean and standard deviation have not changed, find the probability of selecting this certain amount of cigarettes and the mean of those cigarettes, which is our X bar. So sample mean is what we're talking about. See where it's labeled sample mean on section 2? So the sample mean is where we're going to put the sample mean, the grams that is in the question part. It's also up here at the end, but. And then you want your population mean and population standard deviation from the paragraph at the very top. That is your population mean and population standard deviation. Now, don't forget, we have a sample size. So at the bottom, you have to type in your sample size. This is asking for the mean of this number or less. Which probability do we want for less? Left. So we want to copy the left. Remember these yes, no questions. If it's 5% or less, if it's less than 5%, say yes. If it's more than 5%, say no. Five percent would be 0.05 in decimal form. You get the idea of the change here. Since we have a sample size, we're not dealing with just a value. We're dealing with an average value of a certain number that are being drawn out from the sample or from the population. So they are being put into a sample. So that's the sample mean instead of being just a single value. Any questions about number 2? Okay, let's look at number 3. Number 3 says, scores for a common standardized college aptitude test are normally distributed with a mean and a standard deviation. Randomly selected men are given a test preparation course before taking this test. Now, we are going to learn about pre-tests and preparation tests and things like that. And so that's coming, but we don't need to worry about that now. They say, assume that the test has no effect. That way we don't have to worry about post and pre right here. The first question says, if one of the men, if only one is randomly selected, can you take an average of one person? Right? No. You can't take an average if you only have one person. That is the actual score. So if you're dealing with one person, it is X. But in the second part, part 2, it says, if 32 of the men, can I take an average of 32 people? Yeah. So now that's going to be X bar. You see the difference? One score means X. Multiple scores means I have to deal with the average. So that's X bar. Even though we're using the same sheet, I just want you to realize the difference. For part 1, we have that value. So if one of the men is randomly selected, find the probability that his score is, and be careful, this is at least. I think at least is the most difficult. At least is the only L word that means right. Okay, so this is going to be probability to the right. But they say at least this score. So we're looking for that value. That single value is what we're comparing everything to. That's what we put under X. Then you want your mean and standard deviation from above. So for part one, since it's not X bar, you do not need your sample size. You only need your sample size when it is X bar. So this is dealing with X. Make sure you have your probability to the right. So the only thing that I'm going to change for part two, if we have a certain number of men that are randomly selected, find the probability that their mean score is at least the same number. I'm not even changing my score. I'm just going to type in a sample size because now it's X bar, not just X. So we need sample size and then look to see what these numbers, this is going to change your number quite drastically. You still want right because it says least. So I have 41% and 10%. That's a big difference. Yes, no questions are the same. If it's 0.05, underneath 0.05, less means yes, more means no. Any questions there? That was our last question for this section. So any questions on any of the three questions we had? Okay, let's go to our calendar because we've got a lot going on this week. Look at this. We're throwing you right out there, aren't we? All these homeworks are due this week. The two homeworks that are due tomorrow night are actually from before spring break. Okay, so this is all chapter 4. That way, if you didn't do it before spring break and you come back now, you're kind of getting a refresher before the test. So this is 4-1 and 4-2 are both due on Tuesday, the 21st. Then Thursday, the two from today. So the two homeworks we did today, let's see, what's the numbers? Well, 15 and 16. So 15 and 16 are what we worked on today. That's what is going to be due on Thursday. And then in our next class, we will work on the last two sections of chapter 4, which are very short. Okay, it's going to be a lot shorter than today. Those two sections are going to be due on Friday. So you have to turn around and get them done pretty quick, but you got to get those done because your test is coming up. Test, this is going to be test 3, and it covers chapters 3 and 4. So don't forget to go back to all those vocabulary words about the frequency tables, class width, class boundaries, relative frequency, degrees in a pie graph, all that kind of stuff. You've got to remember all those definitions that we covered in, I think that was section 3.3. So make sure you remember that. We do have a practice test that you can use, but I think even better than that, I have a study guide. So let me talk about the study guide today so that if you're trying to get ready to take this test, you'll see this study guide. It's study guide for your practice test, which is the same thing as for your test. Okay, now what this means, what all these numbers mean, Over on the left-hand side means number 1 on the practice test or on the test, numbers 2 through 7 on the practice test and the test, numbers 8 through 10, and so on. Okay, that's the number on the practice test and the test. I tell you what homework it's from. In the middle column, I tell you if it's a vocabulary or symbols, that means notes, or I might tell you the sheet, the Excel sheet. So raw data, group data, the Z-score. I try to go into a little bit of information here for the, instead of just saying Z and T. I didn't tell you section, but I talked about the Z-score. Over on the right-hand column, that's just how many questions are in each pool. So for the second one down where it has 10, 1, 3, 2, 3, 1, for number 2, there's 10 in the pool on your practice test. For number 3, there's only 1. So the question you see on your practice test for number 3, it's going to be the same question on the test. It's just going to have different numbers, but you're going to do it the same way that you practice on the practice test. So that's what those numbers mean over here. So if you see all those 1s, you can pretty much tell which ones you're going to see on the test and which ones you need to go through a whole bunch on the practice test. So for number 2, you're going to do a lot of them on the practice test so that will help you see more questions, so you'll be more familiar with what you're going to see on your test. This test does have 25 questions. It's like our first 2 tests combined. We had a 15 and then a 10. That used to be one test. This test has 25 questions. You have 2 hours. It's the same 2-hour time limit that you're going to have for this test and the next test. So you'll have 2 hours, but you should not have any trouble getting that done in 2 hours. If you do some practice ahead of time. Now, if you just sit down and try to take the test right off the bat, it might not go so well for you. You might run out of time. So do a little bit of practice ahead of time on the practice test. Okay, so that's what the study guide is on there for. The test is due Sunday. So right off the bat, we're coming back, getting 6 homeworks done, 6 homework due dates done, and then having test 3 due on Sunday. So there's a lot. It usually, spring break is usually a week earlier than what we had it this semester. So this is usually our 2nd week back. You guys are going to have a little bit of rough time going at it, especially the people that aren't coming back till later. You're going to have to get started as soon as you get here and get that done. Okay. Anyone have any questions about what's due or anything else? Okay, I'm going to stop the recording and you guys have 15 minutes that you can work on homework. Don't forget about those 2 that we had before break. Get those done.